Jerry Martin is first. Doing okay. We think we finally got a handle on the eyes. Turns out the magic pill was Tylenol. It doesn't fix it, but I can sleep. Let me tell you, that's worth its weight in gold. We're still trying to figure out what we can do to control it better, but at least I can get sleep now. Yeah, let me tell you, sleep deprivation is no joke. I mean, it just messes with you. Where's that one project? Right there. Yeah, I thought it was the Advil, but it turns out then I was freaking out because the Advil stopped working. And it turns out that because I was coincidentally taking the Tylenol with the Advil, they're both having an effect, but the Tylenol's the big one. And doctor said I could take Tylenol basically as long as I want, and it won't hurt me. So I take it twice a day. Really? My hair's all frizzled again. Something else I've been wanting to do. Got this cute little vase, and I want to print this both ways. I want to be able to print that way and also print it that way because that actually kind of looks cool too. So I gotta get rid of the floor on this side and add the floor on this side, so I can print it both ways. It's not as simple as just adding a floor. This I should be able to just remove it. I think I added that floor. I should be able to just lop that off. But this one I have to add the floor and remove the cuts. For the first 6 millimeters of the print. Do anything interesting this week?
I am Groot.
It's pretty hot here, not too bad. That's probably why it's been like 95 degrees here. Let's see what's going to be. Let's see. Looks like it broke. We've been like 93 to 96 most of the week. Hey, Ben. Haven't seen you in a while. But it looks like this week is going to be much cooler. 88, 87, 82, 77, 76. Lots of rain, though. 80, 84. And, well, actually, that makes sense. It's going to be partly cloudy, and that's how you get cooler weather here. You block the sun. Um, so that's not so bad. So the next week's going to be pretty good here. Well, that's the nice thing is that my electric bill last month was $152, which and keep in mind I'm all electric. There's no gas. Um, Cooling in the desert doesn't cost much, even refrigerated cooling. Just because you don't, there's two parts to cooling. People don't realize that there's two aspects anytime you have any kind of cooling. Why does it keep doing this? Am I doing that without consciously realizing it? The When you're air conditioning, there's two things an air conditioner has to do. One has to cool the air. People think that's the most important thing. That I can easily explain. The No, I don't get haircuts. They're too expensive. I do my haircuts myself, and yes, it is time for me to cut it again. I tried letting my hair grow into a ponytail, and that worked okay, but my hair's just not thick enough, and so it got annoying. And I started getting psoriasis again on my scalp, and so I was like, screw it, just clipped it. So I've got the clippers. I got to do it again. The um, Air conditioning, you have to cool the air, and you also have to, and this is actually more important than cooling the air, you have to remove the water. You got to dehumidify. If you don't dehumidify, you just end up clammy and cold. Yeah, it's like $30 for a goddamn haircut around here, and that's before you tip. It's like screw that. But here, because humidity is under 20%, I don't have to remove the moisture. So all the air conditioner has to do is cool the air. And my little 12,000 BTU air conditioner could easily cool this entire house if I could move the air the length of the house. Temperature gradients don't like passing through doorways. So when you have a room with a doorway, if you have yourself a room and you have a doorway and you open up that door, you think, okay, well the air is just going to move from this room to this room. No, it doesn't tend to want to do that. It tends to form like a barrier zone. Like Like when you walk through a doorway, you can actually feel the dramatic temperature change from that room, which is air conditioned, and this room, which isn't. This room's not bad, but because especially I got the ceiling fans going, trying to force the air to move around. But what I really need to do is I need to put ventilation fans in the walls that connect the two rooms together, and I need to physically draw the air from this room into that room, and then another fan on the bottom drawing the air from that room into this room. They don't need to be strong, but they need to be resilient and they need to be quiet. Basically, like you duct air conditioning. That's the reason you have to duct air conditioning. You can't just cool one room and figure, oh, it'll just propagate to the rest of the rooms. Air is an insulator. So it's not the air. The coolness is not going to propagate very well. You need to move the air. Like when I go into the bathroom, you sweat. That's why the new air conditioner was a triple head. Even it's broken now. I can't do anything with it right now. But we got a head in here, a head in Michelle's room, and a head in the center. That's why. Just because instead of trying to put super cool one room, you split it 3 ways. And as far as the Vase mode, that's actually easy to explain. See, probably easiest to show it in the slicer. Yeah, that'll work. God damn it, that 3D interface is so horrible. Okay, so Film Factory. Oh, by the way, let me show you guys what I did this past week. This one came out great. You can see it actually spells the word. And that's integrated into the design. Not bad. Now, there is one problem. This side's backwards. So you're going to want to print 2 and flip 1 so that it's right ways around on both ends. But yeah, that came out pretty cool. I mean, this is silly to do this. This is funny. It's fun to do. It's not very efficient, but it looks damn cool to actually put words into the model and use that as part of the structure. The other one came out because this one started to under extrude for some reason, so I slowed it down. That fixed it. But yeah, same deal. The letters built in. That's really cool. I like that a lot. Now, I knew this was going to be an issue to begin with, and I found an additional issue that I should have known about. This is the diamond one. And this one's not really any good. This one's pretty much just cosmetic because all the diamond is doing is acting as a shock absorber for this here. See? The diamond just allows the outer wall to squish. That's all the diamond really does. It doesn't add much to structural integrity. Well, it adds a little bit. What you really need is the other model. What the? That was good. Did you guys see that? Oh my god. This was sitting on the bed, and the cat jumped up on the bed, landed on top of this, wasn't expecting it to be there. It scared the shit out of him, so he leapt straight up in the air. That's what you just saw. That was good. I love cats. So the one this is mostly cosmetic. To make this really good, you want those diamonds to be connected. So you're basically getting 3 or 4 walls while still being in vase mode. We did that. You saw where we did that. This is the first one. Now this does have another problem. Because the all the way through is on one of the diamonds, it split almost immediately. All I did was give a little squeeze and it split. And that's because the bond point is only these two little points. So to do this one right, I need the all the way through slot to be in between two of the diamonds. So in one of these corrugations, all the way through. Because it's not a true bond. It's not molten plastic being placed on top of molten plastic. It's molten plastic next to molten plastic. So it's kind of like if you have something sticky and you accidentally touch and now it's stuck. But it's not as strong as a proper bond. So the bond surface area needs to be increased. So you don't want your bonds to be a point like this, because otherwise it's just going to split open like that. Actually, maybe that's a slicer issue, because they're all popping. Well, that makes sense. I'm bending this beyond what it was designed for. No, there it goes. It's good. Okay, there we go. Okay. So just make sure your through slot is in between, because you have to have enough meat or it's not going to bond. You'll see that when I show you this. Correct. So you can see here, here's my through. Now in the other one, there's a diamond here. And that means instead of all of this surface area bonding, I only had a little tiny bit here and a little tiny bit here. And the result of that is it breaks open like that, which you don't want. So the solution is to put the line in between two diamonds. Now, the important one is your ribs. Okay, so this is your outer wall, this is your inner wall, and then this is one of the ribs that comes out and attaches. The reason the gaps are critical is because the slicer has to do this. Okay, do you see what it's doing? You're drawing this line here, and then this rib is actually 3 lines. You have the line coming down, the line going across, and then the line going up. You can, but you don't want to do that. That's a one-time solution, and it's a 7-hour print, and you got to test it each time you tweak it like that. And the problem is now, if that part has to mate with another part, well, by adjusting the flow rate, you're essentially adjusting how thick the model is. If I were to fix this by simply adjusting the flow rate, now when I go to insert, a part, if I were to adjust this by simply adjusting the flow rate, if I were to then go to try to insert a part, that part might no longer fit because I made this part thicker, which means now I have to adjust this part too. So it's better to design it correctly to not have that problem, so that you don't have to change your scaling when you go to fit your parts together, because otherwise your parts won't fit together anymore. Now for parts like this where I'm not screwing them together, they're just going to have a sleeve holding them together, you could probably adjust 5% and get away with it, maybe. But that's not going to make as much of a difference as you think. I mean, what's 5% of 0.4? It's not very much. No, the default, well, it depends, okay? So my default gap in here is 0.02 because it draws from this point out. So this gap doesn't actually matter. The reason I make it 0.02 is so that if I scale it a little bit, it never goes below 0.01, because if you go below 0.01, sometimes the slicers and Tinkercad do weird things. So this gap doesn't really matter. This gap should be basically 0. Now this gap here, the gap I create here, let me show you what that actually looks like. Will that stay? I hope that stays. Yes, it does. But how do I show you the model? There is a way to do that. View. I guess I'll show it to you there. Hang on. Okay, so as you know, there's a gap between this slot and this part here. Do I have a model loaded that I can show you that? Sort of, yes. Yes, there we go. Here we go. So you see there's a gap here. So this slot does not go all the way out. Now there's two things that you have to do. One, you need this to bond with this. This is the rib on the inside. So this is these ribs. See the ribs there? Okay. See those ribs? Those ribs need to bond with the outside. Otherwise, it's just two floppy surfaces not really bonded together. And when you don't get a proper bonding, you get a sloppy surface like this. All right? It's nasty because it's too thin. The gap is 2 times your nozzle diameter. It's not a size, it's a relationship. This gap that you design into the model must be 2 times the nozzle diameter. So if you're going to print this with a 0.4 nozzle, that gap needs to be 0.8 millimeters. There is a little bit of wiggle room, so I usually use 0.75 millimeters, which encourages a little bit of better fusion. But any more than that, you start to run into problems. What are the problems you run into? Well, that's actually not a design problem. It's a slicer problem. You need to create a valid tool path. This is a CNC machine. You have a tool head, and you have XY coordinates, and this slicer has to come up with a path for that tool head to follow in order to do what it has to do. This is what you're seeing here. This is the tool path. Now the problem is, if this touches this, the slicer is going to interpret that as a cut. And so instead of getting a rib with an outer wall fused to it, you end up with this. And the problem is, you can only have one of these on the model if you want vase mode. If you want to maintain the advantages of vase mode, the benefits of vase mode, you can only have one of these on the entire model. So if your slicer interprets this as a cut instead of a rib, then what's going to happen is you're going to have another break in the model right here. And now vase mode is broken. It's going to have to stop, move, and retract and draw 2 separate sections, which we're trying to avoid. To avoid that, this gap here has to be large enough to allow a valid tool path, yet small enough to encourage fusion of the plastic between the rib and the outer wall. The minimum, with a little bit of wiggle room, because your slicer is capable of your slicer is slightly flexible. It will say, okay, I'll allow a little bit. So usually 0.5 is enough. But basically, this needs to be 2 times the nozzle diameter. Why does it need to be 2 times the nozzle diameter? Well, it's physics. 2 objects can't occupy the same space at the same time. So it's not a rib. It's not a rib touching a wall. Okay, that's not what you have here. What you have here is a rib touching a wall. Okay, the rib is not a line. It's a tool path. So if the nozzle goes out, the nozzle has to come back. Okay, it can't just jump from here to here. You can, but now you're not in vase mode anymore. Okay? And then when you're not in vase mode anymore, you lose all the advantages. So for a valid tool path, your rib is actually 3 paths. The out path, the turn sideways path, and the return path. And that's what you're seeing here. Let me switch back to this screen. So what you're seeing here is exactly that. It comes down here, it moves over here a minuscule distance, and then it moves up. Now, the outside of the model is this edge right here. The end of the gap that I cut into the model is this edge right here. Well, if you look at this, you'll see why the distance between this point here and this point here has to be 0.8 millimeters. Why? Because this extrusion is 0.4 millimeters, and this extrusion is 0.4 millimeters. 0.4 plus 0.4 is 0.8. Now you can see I have a slight overlap here. You can see this is actually embedding slightly into that, and that's because I made my gap 0.75. The slicer will permit a certain amount of overlap. But if I were to make this, 0.5, the slicer would then say, okay, that's a cut. And it would then extend this line all the way through the model, and you'd have two separate pieces printing here. So to avoid that, I have to be big enough to permit these two objects to physically exist, and small enough that they touch each other so I get fusion. That's why whenever somebody downloads one of my rockets, the first thing they have to do is a test print. Correct. That's what I do. Now, how to do that in Fusion? I guess Fusion, you would just make your spacing 0.02 since you're not actually cutting. In Fusion, you're building. You're drawing a blueprint. And I don't know how to do this in Fusion. I could do it as a one-off, but I don't know how to do it parametrically. Like, what would be neat is if I could tell Fusion, okay, hey, Mike, if I could tell Fusion that I want this line here to be conformal, to follow the shape of the outer wall. That's not the same thing. Thin wall equals 0.02 is not the same thing. Thin wall equals 0.02 is this, the thickness of this wall itself. Okay, that's thin wall. This is not a wall. This is a gap. See? There's no wall there. That's a gap. I'm taking a solid object and I'm cutting a slice into it. These are the tubes that I make. The rocket tubes that I make. So I figured out that I can, let me show you the other one because it's easier to look at. I figured out that I can put words as part of the structure of the tube. And this is all vase mode. And so now it says NAR all the way around. And that's my tube for a rocket. Just for fun. I was like, oh, I can do that. It's a pain in the butt, but it's cool. So let's see, go back to the slicer here. Well, again, you can design that, but it's probably not going to work because your slicer is going to flip its shit. Your slicer is not going to print a 0.02 wall. It's just not. It's going to erase that. Anything you make that's 0.02 thick, the slicer is just going to delete as a defect. At least as far as I know. You could try it. I don't know how it's going to work. Dimensioning is also going to be difficult because you're defining a wall that cannot be printed. You can force the printer to print it, but it's not possible. You're printing something that's impossible. You can't print a 0.02 wall. It's going to come out something much larger than 0.02 because that's the plastic coming out of the nozzle. Even with a 0.1 millimeter nozzle, you'd have a tough time extruding 20% flow rate, which is what you'd have to do to 10% flow rate, which is what you'd have to do to get a 0.02 wall. You got to remember, Fusion works from the ground up. You're building the model like a blueprint, and then you're using that blueprint to construct the model. Tinkercad is the opposite. you are taking physical objects and you are adding and subtracting from those physical objects. So if I want to put a hole in the middle of the cylinder, well, in Fusion, you would draw the outer wall section and then rotate that wall. In Tinkercad, that's not what I do. I would select this object, shrink it, turn it into a hole, and then join the two together. So Tinkercad is more like modeling. Fusion is more like CAD. And so the way you think about that is important in your design. See, I don't even know how I would do this in Fusion. While sticking with blueprints so that you retain parametricity. I just don't know how to do that. I'm not skilled enough in Fusion to know how to do that. What I do know is the end result you need to have is this gap needs to be 2 times the nozzle diameter. Otherwise, in the slicer, you'll run into one of two problems. Either you won't have a valid tool path because this will break through this, or you'll have a perfectly valid tool path, but these won't fuse together. And if they don't fuse together, you end up with a weak part. You don't get the structural integrity boost of having an integrated structure. And you see the letters are just extensions of a slot. You see, the slot starts here, and then I just change it into a letter. But the same thing, down here, a little rib comes within 0.75, and then down here again, a little rib comes within 0.75, and you just end up back here. What I really should do is this should have another rib going this way, 0.75, but that's a lot harder to do. I'd have to put a cut in here, make that cut even with this wall, and then move it 0.75 to get that same result. The other thing I could do is I could put a slice right through the middle of the N here, making these two separate parts, and then just break through here, print this part, break through here, print this part. I could do that too. The rest of the letters didn't require that. The R was pretty simple. But again, I had to put a cut through here because otherwise the R is 2 components. This component and this component. You can't have that in Vase mode. They have to be connected. So I had to put a slice through here so that now this R is all one piece. Same thing with the A. You have 1 component, 2 components. You can't do that in Vase mode. I'm not sure. As far as Cura, I abandoned Cura for my Vase mode models because I have never once been able to successfully slice in Cura with these complex Vase mode models. It just decimates them every time. It destroys them. If you want to try, if you go to my printables page, you'll see the rocket that I have there. It uses this trick. If you can make it slice in Cura, whew, properly slice in Cura. No retractions, no travel movements. 1 continuous Vase mode extrusion. I have been completely unsuccessful in convincing Cura to do that. So far, it's either Simplify 3D or Prusa Slicer. So same thing here. I had to put a little slot so that instead of being 2 triangles, it was 1 big shape. And then so you can see it creates a continuous tool path. You come in here, you form your letter, and then you come out here. So it never has to stop. There's no breaks. There's no separations. The only break between the inside and the outside is this one right here. So this one here goes all the way through because you have to have some way of connecting the inside to the outside. But every other one stops. It's just a rib. All the rest of these are just ribs. Now one easy way to check it, because it's sometimes these slicers do weird things. Make sure you can see the tool head retractions and travel moves. And what you do is you just run through the model. You just watch that tool head, make sure it doesn't move. If that tool head ever moves, that indicates a problem, and I do have a problem here. did that happen? See? I got a gap here. This sometimes happens. The slicer does weird things. And I don't know why it does it. It jumps up one. I don't know why it does that. It didn't travel move. It just jumped up one for some reason. Sometimes it's as simple as, messing with the model. So rotate a little bit. And sometimes that'll do it. Yeah, there it goes. That fixed it. Don't ask me why. There's no rhyme or reason. Basically, there's a glitch in the slicing algorithm for Vase mode that when you try to, and they all have the same problem. That same glitch will appear in Prusa. The same glitch will appear in Cura. So they're all using the same algorithm. Yes, actually, I did that. Hang on, you'll like this. That's one of the things that I did to increase strength. Let's see. I think it's this one. Yep. So that's exactly what I did with this one here. Oh, that completely broke it. Wow. That just puked and said, nope. Oh, 1 millimeter. Oh, wow. That's why it wasn't working right. Okay. Derp. There we go. Good. So that's exactly what I did on this model here. The triangle is actually shaped the same as the cylinder. I used a cut to shape the triangle the same as the cylinder. And I did that so that I would have this really good, serious bond right here. Now, I also realized that I need to modify this. This is too small. That's going to crack open. And I don't want that. Where's my pass-through? Did I not do a pass-through? I mean, this may be a screwed up one where I didn't do a pass-through. There it is. See, that's no bueno. That's not going to work. See, all the bonding is right there and right there. That's just not going to work. So there's two ways I can fix that. Well, first, I can't fix that here. The only way to fix that is I have to move this cut-through rib over to here. So I have a normal rib. This will always fail. This is going to fail just like this. It's just going to do this. There's just not enough material. It's like, instead of having this as the bond, I have this as the bond. Like that. And that's just going to pull apart. So the solution to that is to put the one slot that goes all the way through in between two of the shapes. But yes, that's what I did here. That I added this foot. So this triangle connects to both sides. Now what I should really do, can I? One thing that I was thinking of doing, it's really complicated, but in theory, if I could figure it out, I only have to do it once and then I can duplicate it. So instead of having a triangle, you'd have an hourglass. This way you'd have an increased foot size on both sides, reinforcing both walls. And then on top of that, have, instead of it cut in the middle like this, have it be a path. So it would come in this way and would come over here and wrap around and come back and then go up and draw this. That would, instead of me having a bond, oh, you couldn't even see that. So instead of having a triangle have an hourglass, so I'd have an increased bonding foot on both sides, and then on this side, instead of having it just come in like this, have this be a complicated path that comes in here, then goes over here and comes back, and then comes up. If I did that, then you would have something more like this. You'd have more like this holding it together. So instead of having this, you'd have this, a hook. It's just designing that is really hard. One of the reasons the walls are relatively thick on these models is because I need that path to be long enough that you actually get fusion. If that path is too short, you don't get fusion. As you can see, it just, that one's fine, but it just pops open. All you have to do is, you can see this one here, it popped open on the inside here too. The outside doesn't pop open because the outside's one continuous wall. It's not a bond. But the inside is just a trivial bond that connects them together. And there's just not enough surface area. There's not enough plastic touching each other. So let's see what I can do with that. Yeah, some kind of a hook or dovetail, something to help it bond. So let's do this. It should be this. Nope. Yeah, I can start from this. It's the same model. So let's see here. Excuse me. Oh yeah, I'm trying to do something that doesn't work. Is there a reason why this is? Oh, it's catching up. Okay. Let's get rid of this for now. I don't need it. Oh. Let's get you out of here for now, since you're in the way. There's probably a whole bunch of you. No, there isn't. Okay. Now, which one goes all the way through? There it is. Okay. So this, I just need to rotate and take it out of the path there. Join it with this. And I don't want the whole goddamn thing. Why would you grab the whole goddamn thing? Idiot. Why is it grabbing the whole fucking thing? What? That doesn't even make any sense. Those are two separate components. Am I not grabbing it? Is this model not loaded? There it is. Well, why couldn't... Oh, these are all together. Why can't I separate them? These are all one model, see? But why can't I split it? Did I export and re-upload and join these at some point? I might have. So I have to go to this one. I may have simplified the model so I can't split it apart anymore. Come on, finish loading. There we go. Okay. Let's shorten this to make it easier to play with. This is a symmetrical object, so I can always, stretch it out as long as I want. Are we on the right screen? No, we're not. There we go. Let's see. Okay, so first things first, let's create our blocks. Do you have to be in the way, no matter what I do? Okay, now they're all centered. Let's take these two. Let's make sure they are properly centered. Yes, they are. Okay. So I need to Control D this, make it a hollow. Control D it again. One has to join with this one. This should not be taking very long. This is a simple operation. This one cuts this one. Good. These need to be hollow. This needs to be moved this way, negative 0.75. This one needs to move this way, 0.75. My cut tools are prepared. Now I need to create the object that we're going to cut. I would like it to be round, not square. So probably the easiest way is to just drop it into the square. Okay. Take that and this, a line on this one. It is already centered. Okay. Now we can take one of these and do this. That's actually a pretty good curve. So let's make this 5 millimeters. And now we have to recenter on this piece here. We can do this. Okay. Now we take this and join it as one piece. We connect it to this red one. Center on the red one. We are already centered. Okay. That should be it. Let's hide this. This should be the new rib. Unhide. And there we go. Now we have our hourglass shaped rib. And it's conformal and properly shaped. You know, there is a really sneaky way that I can make this rib not have any of the gapping problems. Oh, that's sneaky. That's so sneaky. The only bad thing is it's gonna add a lot of plastic. But I can minimize that. Oh, this is so fucking sneaky. Oh, you're gonna love that. You're gonna love this. Yeah, this is gonna be great. Oh boy. No one says the rib has to be here. The rib can be freaking anywhere. Oh boy, this is gonna be sneaky. Let's see, what do I want to? Let's make it 15 by 15. How does that look? Let's go 10 by 10. Yeah, I kind of dig that. Yeah. Okay, now. This only needs to be 0.02. This is a cut. So I should be able to Control D this, make it taller, easier to mess with. And then, so 0.02. Let me think. So I need 4. Because it's going to be 0.2 on each side. So 9.6. No. 9.96? 96. 9.96. Turn that into a hole. We got to center these two. Join them. That did not work. Why didn't that work? Because I'm doing such tiny slices. That'll do it. What the fuck? Did I do a scalar difference? I do not want both of you. There we go. Oh yeah. Do you see what I'm doing yet? Do you see what I'm doing? This is such a cheat. Oh boy, this is such a cheat. But this is gonna be good. I never thought of this before. So all I need to do is take that and that, cut, turn that into a hole, join it with this. There. Now the rib is an arc that comes in from off the side of the hourglass, and the hourglass will fully meld with the inside and the outside over more than 5 millimeters worth of plastic. Oh, that's evil. And just because I'm a stinking fancy pants and I want to do it, do I go the crazy route? Why not? There's no reason not to. Let's just try it. Control D, rotate this way, and then do the same thing over here. And that'll be the connection to the outside. So this one stays separate. This one gets joined with this one. And then we Control D this, and we start our rotation. That's just wrong. That's so cool. Oh, I need to see if this works. So let's take this, hide you, delete all of you, join all of you. we clean? Oh, that is so fucking cool. Now these just don't exist anymore. These little gaps here just don't exist anymore. They're now replaced with this little arc. And then it can draw this. And it's okay if this is a weak point. The stress points are the inside and outside skin. And now the inside and outside skin are monolithic. I mean, that's going to add print time, no question. It's going to add a little bit to print time. But it looks cool as hell. Why did you do that? Okay, that is really cool. We're going to call this one... I need a cool name for this. We're going to call it Timeless. Now, the only problem I might have is... No, that should be enough. Because this is the gap I need. That's out to here. That's more than enough for it to make that turn, so we're fine. Oh, that's cool. No one scaled up to 1mm size. That's going to make a strong as hell part. I mean, it's going to use a lot of plastic, but it's going to be so strong. Oh. And my hair's all screwy again. I must be touching it or something. And like scratching at it or something. Come on. Export the damn model. What is taking so long? Control D. Let's do the corrugation. This probably doesn't need the corrugation. I'm going to do it anyway. Oh, that's slick. That is so slick. I really hope that works. It should. I mean, I all the rules are adhered to, so it should work fine. Hey, Ciro, how are you doing? We are waiting patiently for Tinkercad to export this model. This is a slightly complex model, so I get it. Wait, that just eliminates pretty much every problem I had. I'm pretty good. Not bad. I'm printing this one now, but this one I made the same mistake. I have the slot going through here, which means that's going to be a weak point. It's going to break right there. Although with this one being integrated, it'll be a little more resilient. Ah, there it goes. Now we take this and this and join them together. This will give me my corrugated outer skin, which will add just a tiny bit more strength. There we go. So this one is timeless-co for corrugated. So you guys know why I call it timeless? is going to be so cool if this works. It should. There shouldn't be anything that would cause it to fail. Look at that. Oh, that's a work of art. Where's my double? Uh-oh, nope, it's broken. There it is. There's the double. There's the yin-yang. That connects the inside to the outside. Then the rest are all on the inside. Oh, that's hot. Oh, man, I might just have to cancel that current one printing and get this one started. And it looks beautiful. And it's not too bad on the plastic either. It's a little high. It's 106 grams, 107 grams. I'd have liked to have gotten that below 100 grams. But hey, you know, it's gonna look cool as hell and be strong as freaking hell. I could make the hourglasses a little deeper, the arc a little deeper, and that would help with the No, it wouldn't. It would still use the same amount of material. Oh, very nice. Let me see everything good. The tool head is not moving. I don't see any gaps forming. So no glitches. Damn, that looks good. This is a lot of wasted plastic right here. It's a whole lot of wasted plastic. Hey, Bale. Cumulatively, that adds a lot of weight right there because it's a double wall. But it means that these walls here, as you can see, are fully fused. Jesus, that's going to be strong. Now, even if one of these does crack, it won't compromise the model. And it'd be pretty hard for this to crack since this is a pretty good long curve here, smooth curve. So that should be a pretty good bond right there. That's cool. I like that a lot. Let's get this on a memory card. Juice box. I can leave them in there. Let's just dump them here. Okay, let's make sure my settings are good. Okay, this should not require any over extrusion. 4-4. No, I'm going to leave retract. Even though it doesn't need retraction, I leave retraction on so that if it does incorrect retraction somewhere, I can see it in the preview. I just made it right now. I literally just invented the idea right now. I do vase mode. Like this. This is a vase mode print. Even all the letters, they're all vase mode. That's when you can read it. NAR. Association of Rocketry, not Rifle Association. And then I have other models. I do all of my models. I have a thing for vase mode. I do everything in vase mode. And I create multi-surface complex structures that use vase mode. But one of the problems that we had is when we added those internal shapes to strengthen the part, it created a weakness. And that weakness was right there because there's just not enough plastic to bond. And so this is the latest design. Let's see here. So the way this one works is that here's your input output. So this connects the inside to the outside, and then each of these hourglasses are actually self-contained. So the way this works is the nozzle will come this way. It'll come up here, out here, over here, around, over here, come up, come back here, and then continue. This here and this here is actually two walls. And it'll do that all the way around until it gets to this one, where instead of coming back here again, it goes to the outside. And now it draws the entire outside of the model, comes back to here, comes back inside, and then continues the inside. This way I can print this, what's basically a 4-perimeter vase mode model with structure inside for strength, and it's all vase mode compatible. Now, vase mode can be lightweight, but vase mode's not just for lightweight. Vase mode has other advantages. One of the primary points where you get imperfections in a model is when you have retractions and travel moves. Well, vase mode has no retractions and it has no travel moves. It's one continuous extrusion from start to finish without stopping. So if I could delaminate this part, if I can grab the end of it and start pulling it, you know, a regular model, you're going to get thousands and thousands of pieces. This model will unravel into one long string because there's no stops, there's no retractions, there's no travel moves. And the advantage is you get one continuous extrusion. So the way I describe it to people is that print this in vase mode. Well, you can't, because you have the outside to print and then you have the inside to print. And you can't do that with vase mode because it would have to stop somewhere on the outside. Hey, DeWitt. And it would have to jump to the inside and then print that. Well, that's pretty simple to fix. Print a C. Well, now you can do it. You can print the outside, and then you can print the inside, inside, outside, inside, without ever having to lift the nozzle. Okay? So a good way to think of it is you have to draw this with a pen on paper, but you cannot lift the pen off the paper, and you cannot cross over another line. If you can do that, that's vase mode. That's a vase mode toolpath. And no trickery like folding the paper. No, it's not a trick, it's a toolpath. So if you can draw the shape without ever lifting the pen and without crossing over another line, then you have vase mode. Now, theoretically, there's no reason we can't cross over another line and still be in vase mode. The problem is, how would the slicer know the difference? Because technically, the slicer already does this. When you print grid infill, it prints, one set of lines, blah, 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 and then it comes back and prints the other set of lines over top of the first set of lines. So the only reason that you can't cross over lines is that there's no way to tell the slicer and the toolpath generation that, cross over this line as if that line's not there. There's no way to tell it to do that. Maybe one day we'll figure out a way to tell it to do that. But for now, you have to model it that way. And that means in your model, let's see, a good way of showing it would be something big and, here we go, something big and beefy. So for example, here's a little vase that I printed for a funnel. It's just a really heavy-duty funnel. You could beat someone with this and you'll kill them. So you can see there's two walls. There's an inside wall and there's an outside wall, and there's ribs connecting them. Well, one of those ribs goes all the way through. That's your C. Okay, so you know how you can print the C in vase mode? Well, all I did was close the C. Yet there's still technically an opening right there. But that opening is so small that when the nozzle passes by, the plastic melts together. But that needs to have surface area. Like this here is a very good bond. This here is not a very good bond. The reason that this broke like this is because that bond right there is one of these. It's a teeny tiny bond. And to get around that, well, I've changed it. And here's what I did. So instead of having it cut right through here, which is what I would normally do, this here would then end up being one of those little point bonds like this. So instead, I come in from the side here with an arc. And now it can draw this entire shape with no break. And that break is a very strong arc to someplace else on the inner wall. Can this still break? Yes. But now, instead of this being a point like this, it's a line. And that line is more like this instead of this. So this should be really freaking strong. The process, I can integrate design into this that gives me incredible strength without any defects. So on the big model, you can see this, that big seam right there, that's the one that goes all the way through. While the rest of these ribs just go to the outside edge and touch it so they fuse. And the result is you have now this is not a lightweight vase. This is a very heavy vase. It's printed with a 1 millimeter nozzle and it's 2 walls. This is a very heavy part. This is like 225 grams of plastic right here. You could beat someone to death with this. But the advantages of vase mode, no, actually it's faster to print. Much faster to print. Because it's like turning off retractions and travel moves. So it prints that much faster. See, vase mode makes... vase mode can make very lightweight parts. And in some cases it does. Like, for example, this is a box that I'm working on. And this is actually reasonably heavy, but it's pretty lightweight considering its dimensions and how thick it is. And that's partially due to being able to print this in vase mode. Vase mode doesn't have to be light, though. You know, I got this big giant funnel I made for filling up my 5-gallon water jugs. Right, that fits right into the neck of the 5-gallon jug, and now I don't have to be careful pouring the water. Just pour it right in. And because it's double wall, and that double wall goes all the way down, it's already ventilated. So it's open down here, and it's open up here, so air can get out. But there are many advantages to vase mode, and using a tiny bit of plastic is only one of the advantages. Now, doing what I'm doing, I'm giving up the lightweight advantage. But that's okay, because I need strength. I need this part to be strong enough to survive going 600 miles an hour and then landing under a parachute without breaking. So what I'm doing is I'm giving up the strength, I'm giving up the weight part. But I'm keeping all the other advantages of vase mode. Well, the other advantages of vase mode are no retractions, no travel moves. That means imperfections in the model are unlikely. Also, print failure is unlikely in vase mode if you design the part properly. If you design a bad part and you try to force it to print vase mode, well, the failure is your fault, okay? On the assumption that the part is correctly vase mode compliant. Print failure is virtually non-existent, because print failure usually comes from a layer shift or a glitch or an extrusion failure. And those usually occur during retractions and travel moves. Well, this has no retractions and it has no travel moves. So you eliminate that failure mode, or at least reduce that failure mode dramatically. You also have the advantage of monolithic strength. Instead of having... Well, it doesn't mean no clogged nozzle, but it means the leading reasons for a clogged nozzle are less likely to occur. Like, for example, I found out that I can print some of these models without a cooling fan. I'm not talking about a parts cooling fan. I'm talking about the hot end cooling fan. I don't even get heat creep with the 1 millimeter nozzle, because I'm shoving so much goddamn plastic through that nozzle that it can barely heat up the plastic, and there's not enough heat left over to cause heat creep. Because what usually happens with heat creep is you're pushing, and then you retract, and that plastic up here in the retraction zone is both soft from being close to the hot end, and now it's hot from the heat creep. It bulges and it jams. Well, I'm going one way. I'm never doing this. I'm only going one way continuously. And it's when you do this, you'll be fine, and then you retract and then jam, you're clogged. So no retraction doesn't eliminate clogs, but it definitely makes them harder. I realized I was printing without a hot end cooling fan. And I switched to a different print and it kept jamming up. I'm like, what the hell? And I was, oh shit, the hot end fan's not working. And I was like, how did that other print work? It wasn't working because it was unplugged. You know, I had the wires backwards, and I had the parts cooling fan turned off, so now the hot end fan was turned off. And I realized it was because it was in vase mode. So the continuous stream of plastic being pushed through didn't give it a chance to heat creep. Don't go doing that, but you know, the point is you reduce the likelihood of failure by using vase mode. And then if you do crazy things like this, where you come up with a really complex design like this, this is an engineered design, okay? So first of all, there's an actual 5mm footprint joining this inside with this outside on both sides. So this larger footprint means a very strong bond. And then the arc is a curve. Curves are stronger. They use less plastic. And also curves act as shock absorbers. So the inner and outer wall will now be more flexible when they're compressed. So they'll be more likely to flex instead of break. And then this eliminates the soft point break problem that I have that causes this to happen. Okay. Now I could solve that also by simply moving the pass-through in between two diamonds. That would also solve that problem. Although you would still have a problem with this inside joint going cracky when you squeezed it. But it's less likely to break. So I get now a continuous extrusion, monolithic, engineered structural part that has no retractions and no travel movements on the printer. So it's easier to print, faster to print, stronger to print, and more resilient against errors when printing. I call that plus all around. I mean, yes, it's a pain in the ass to design these parts, but you only have to do it once. Once I design this part and it works, then I just hit print, hit print, hit print, hit print. I just keep hitting print, no big deal. Now, of course, doing a complex print like this, I lose out on my ability to thread the parts together. You can't do that anymore. But that's okay. For these bigger models, you're not going to want to thread them together. You're going to want to glue them together so they're stronger, because then the threads become the weak point. But yeah, this I'm excited to print this. This looks really cool. Now, don't get me wrong, this is going to be a pretty heavy model, but this should be comparable to a heavy wall tube with like 2 wraps of veil. You know, fiberglass veil. This should be pretty comparable to that as far as strength. And I'm betting you the same size tube made that way will be heavier than this. And then, of course, there's other advantages. I can build the launch lug into this. I can design it to build it right into the model. I can design the, well, actually, if I put a hole in the nose cone, I can put the launch lug right through one of these openings. If you use a launch rod, yeah, that'll work. Ooh, I might do that just because it'll be fun. And then, of course, I can scale this up for big models. So let's save this. Timeless CO. Yes. And even though the corrugation makes it stronger, some people might not want the corrugation. So I also have one without the corrugation on the outside. So that's the same exact thing, but without those little dimples on the outside. No, I'll never make any money off of these. I will sell them. They will be for sale at some point. With rockets, it's not as easy as just post it and sell it. First of all, if you're a member of my Patreon, you get all my models for free. Just ask, you can have whatever you want if you're a member of my Patreon. But everyone else, I have to fly the model first. It's a missile. It's going 400, 600 miles an hour. I got to make sure it works before I go selling it to people. Although the nice thing is, with these heavy-duty models like this, I don't have to test every model. Once I know this wall design is functional and works correctly, I don't have to I don't have to test every one. I just have to test one. So I'm going to print up one of these and, you know, give it away to somebody to get them to fly it for me. So that's that one. Now, let's change to the larger one. So 111. No, I want 0.8. 0.8. Okay, that's fine. 0.5. I bet you I can get away with 0.6. I bet you I can get away with 0.6. Okay. Speed. 10 should be fine on this one. I have to slow the other one down, but I can do that on the printer. Let's see. I'm betting you I can get away with 0.6. Although 0.5 will look better. Okay, center. And what we're going to do is double this to 160, since we're doubling the nozzle diameter. But I do have to make it a tiny bit shorter, 399.5. Otherwise it runs into... Oh, that one didn't give me an error. Ah, that one didn't error. I have over 100 printers, so I just pick a printer. These will be printed on the LK5 Pro from Longer and the Odin Fucus, Odin F5, which is a company that doesn't exist anymore, sadly. It's too bad. It's a pretty nice printer. Okay. Yeah, something I think if I added them all up, I have like 160 printers out in the container. I can never hook them all up because I don't have that much electricity here. Okay. Any glitches? Any errors? Now this is 850 grams per tube section. Nice. But this is a 160 millimeter model, which is 160 divided by 25.4. This is a 6.3 inch model. So this is a 6-inch airframe. I think 850 grams for a 6-inch airframe is not bad. And it'll be 400 millimeters long. I need to build a taller printer. I need to build a 1 meter tall printer. It doesn't need to be more than 300 by 300, but it needs to be about a meter tall. Well, in the early days when printer manufacturers were just handing out printers like candy to reviewers, I received a lot of printers. I didn't pay for almost all of them. The only ones I paid for my MakerBot Mini, I paid for my Wanhao Duplicator i3v2, and I paid for my 11 Ender 2s. There's a couple of used printers that I bought that I paid for off of Craigslist, but otherwise manufacturers sent me these printers for free. That's the only way you get that many printers. Okay, so this is going to have to be exported separately. Damn it, that looks good. That is going to be so freaking strong. Now I got to design the couplers, nose cones, motor mounts. Well, the first thing you the easiest the easiest thing to sell is other people's models because they've already done the work to make them. What you have to look for is to make sure you're allowed to, because people will shun you if you violate these rules. So when you go to Thingiverse or Printables and you click on a model, This is very important. Okay. So you go here, and here, license. So see this one here? This one says Creative Commons Attribution Non-Commercial. That means you cannot sell this model unless you ask permission. He might give you permission. He might say, go ahead. He might say, no, I don't want you to. Or he might say, okay, how much am I going to get? And then you got to figure that out. Like this one here. This one here, see, commercial use, not allowed. Okay? So you figure out what models are popular and you offer them available. You know, print out a few of them and, you know, this way you have them ready to ship. But make sure you're allowed to print it. This one here, for example, this allows commercial use. Okay? Now, it doesn't allow sharing without attribution. That means in every single one of these you sell, you know, on your receipt or a note card saying, you know, thanks to, Happy Maker at happymakeronprintables.com for this wonderful model. You know, give attribution. Make sure you tell people who designed the model and that you're just printing it. You know, print it with permission because he gave you permission by saying it's commercially usable. Okay? And then you could print this, for example. And you could sell this legally. You'd be allowed to do that. Just make sure you give attribution. You know, on your receipt, you know, include a little note, you know who he is, and, you know, basically include this address, printables.com/@happymaker. And that way you're giving him attribution for being the one who designed the model. You'll find there's a surprisingly large number of models out there that allow commercial usage. People who design models like this tend to not allow commercial usage because that's how they make their living. They're good at it. They know what they're doing. And they're smart enough to know that, yeah, I don't want everybody else making the money when I could be making the money. So this one says non-commercial, so you can't make that commercial. But that's what you do. You just go in there and you check and see if they allow commercial usage. The other thing you could do is design your own models. Now, how do you know what model to design? Well, you got to find a niche to fill. Usually, the way I've seen people do it is they find a local company that has a need for a particular part that they're always replacing, for example. Well, I can model that out of 3D printing, and it's strong enough as a 3D print to perform the function. So I'll try making it and selling it, for example. But that's a lot of that's luck and happenstance. I'm probably not the right person to be asking that question to. I can give you the very basics, but more detail, you'd have to talk to somebody. Oh, that's so cute. Oh, that's adorable. Yeah, we're downloading that. Yeah, that's just too adorable. Wow. I love those little lizards. Oh, that's adorable. Yep, I'll be printing one of those. Nope, I saw that. I was like, yeah, mine. Yeah, I'm definitely gonna. At some point, that's gonna get printed. That's just too absolutely adorable not to print. um, but find a niche that you can fill, where you can offer something. One of the things I'm going to try, I have no idea if it's going to succeed. It might be total garbage. I don't know. I'm going to try making these little vases. So I designed these vases. This is the little one. And they'll all be petchy so they can handle, the heat. And I've made a whole bunch of different models. So for example, here's the 2D model. Technically it's three-dimensional, but I call it 2D because it's skinny. So it's like two-sided, so two walls, so to speak. So there's a skinny one. And then I have the triangular one called 3D. This one, I love this. It's beautiful. It's all in vase mode. This is 100 times prettier than what you're seeing on your screen because it's got a golden iridescence that just does not translate to video. And then I have square ones up there. And then I have 5-sided, and I still need to make a 6-sided. There's the pentagon. Came out really nice. And I'm also designing these little boxes. So the way this works, you have a lid that slides in here, and you can take the lid out and slide it in the back for storage. It's just a little trinket box you can put stuff in. But I wanted to see if I could do curved walls with the Vase mode ribs. And I spent a week making failed prints, tweaking and adjusting, just to find out that it was my stupid ass fault, because I accidentally sent the nozzle diameter to 0.3 millimeters, and that's why it wasn't fusing. Yeah, this one came out real nice. Now I'm not going to sell the vases; they're not going to be worth very much. But what I'm going to do is I'm going to fill them, put foam in here, marbles in here, and then I'm going to buy artificial flowers, and I'm going to make artificial flower arrangements. Or I could make a version with a potted plant that'll fit in here, for example. You go buy a little potted plant at the grocery store and stick it in there. The idea is to sell arrangements, to sell pretty arrangements. Probably not to individuals too much, but businesses might enjoy this. So, you make a Valentine's one out of colors like this, for example. St. Patrick's, make a green one. And, maybe build up a small business to sell to local companies that, because I noticed this one lady, she made these flower pens. She took a green pen and some green metallic duct tape. She took a single artificial flower and she taped it to the pen. So the pen became a flower. And then she would stick that in a vase. And you'd have a vase of flowers, but they were pens. And so when patients came in, they would pick a flower to sign, the doctor's paperwork with. And I was like, that's really cool. I was like, can I go a step further? I used to print pens. And so what I want to do is I found a couple of commercial use allowed designs. I'll give attribution, of course, where I can print a pen that uses a Pilot G2 refill. That's my favorite pen refill, the Pilot G2. And I'm going to modify it to have an actual slot to accept an artificial flower. So there won't be no ugly duct tape. And so I can print out a really nice pen with a flower on top and sell those. I don't know how well they're going to sell. I want one myself, so it's not really any work for me to make one. And if it doesn't sell, I just don't print them. At first, I'll make them bespoke. So I'll print them on demand. You say, okay, I would like one, and then I'll print it, at least for the pens. For the centerpieces, those you won't get a say. I will make a few of them, and that's what will be available. This way I don't have to worry about, me forgetting to do what I need to do to make one for somebody, and now they're angry at me because I'm not on time. So in the beginning, it'll be, you pick what I have. And, you want that one? Okay, that one's yours. And I have no idea if it's going to work. It might be a complete flop. Who knows? I'm going to try just because I need money. I have 160 3D printers and 600 kilograms of plastic. I want to leverage it somehow. Although I can't use most of the plastic for these because they have to be PETG. In this climate that we live in, I can't use PLA for something that could be exposed to sunlight. Yeah, this is a blood diamond red from Atomic Filament. Atomic Filament is not cheap. It's $32 to $35 a kilogram. But they make some of the best plastic there is. Some of the colors they have, this hot bubblegum, it's not hot bubblegum, it's a hot pink color of some kind, is just absolutely stunning. I love this color. This is also one of their colors. I want to say, I forget what this is called. But this is also one of their colors. This is one of their colors. And this is like a graphite gunmetal. That's also one of their colors. And the gold is one of their colors. I love Atomic Filament. They're just very expensive, so I can't get them very often. But this is their blood diamond red. It's got a very fine mica glitter and a golden iridescence that simply does not come up on camera. I have yet to figure out a way to make that show up. Oh, you can kind of see it there. You can kind of see that golden color there. And it's not this brick red that you're seeing in the video. It's this deep, lustrous ruby red. I mean, it looks like a ruby. It's such a beautiful color. God, I love this color. But yeah, that's one of my favorites. I love the triangle. For some reason, the triangle just looks really nice. So I show off the infill on the bottom, and I go through all the work to make a custom slicer profile so it prints perfectly every time. And of course, it's all vase mode. The bottom's not vase mode, but the top's all vase mode. And but you know, find a niche, try to fill it. The problem with making generic stuff and selling it online, you have two problems. One, people want to nickel and dime you down to plastic cost. Well, where do I make my money then? You see what I mean? They don't care. They want it as cheap as possible. If you don't make money, it's not my problem. You see, you get that problem. And then the other problem is if it turns out that what you're selling is hot and it actually, you know, fills a need, there'll be 10 people duplicating it within a week. You know, because it's a 3D model. Anybody else can make the same model. You know, anybody else can, you know, come up with this. You know, I have a little bit of an edge because I'm very good at manipulating these vase mode models. So I have a little bit of an edge. But this design in general is nothing special. And online, people aren't going to see the benefits of this. It's not until you pick it up and you realize, holy shit, that's light. And you realize how strong it is, even though it's a vase mode model. That's all really. I mean, here's I made this SD card case. It's all vase mode. Even all the slots, it's all vase mode. This whole thing is all vase mode. And that just slips over just like that, doesn't fall off. Well, if the cards come out, it's going to push it off, but you know, it doesn't tend to slide out on its own. Whoop. But you got your individual slots that hold the SD cards. I'm going to have to tighten that up a little bit. That should not have fallen out. I purposely made it tight enough so that it wouldn't do that. But then again, I printed this in the wintertime, and now it's summertime, so it's expanded a little bit. So I got to tighten up the tolerances a little bit. But yeah, that should not. It is coming off. Huh. I'll have to tighten that up a little bit. But that came out really nice. This is a protopasta color. That just came out really nice. But that's my own design. And then sometimes I'll get ideas like this. I haven't done anything with it yet. But I got these off of AliExpress. It's a little cookie cutter. And it's really cool too because it cuts out the shape. And then to get the cookie out, you use double duty. There's a spring in here. And it pushes the cookie out while also imprinting that design on the cookie. That's cool. So you go give it an imprint and then you push it out and it drops the cookie and you have a little cookie. So I'm thinking we should be able to 3D print something like this. This should be 3D printable. So it'd be neat to be able to make our own, you know, reasonably advanced cookie cutter designs. So I'd like to try to play with that. And, so I ordered, it was only $2 to order a set of 4 of them. So I ordered a few to play with and see how I like it. All right, that's it for this week. I might not be on next Wednesday because I'll be driving home from Denver next Wednesday. So I'll either do a stream late Wednesday night, depending on how tired I am, or just do one Thursday morning. Because I also won't be doing a stream the first week of August because I'll be at Naram. It's going to be a tricky trip to Naram this year. It's going to be real tight. Because I have no money. So the guy who is let me stay in his room is going. And he's going to let me stay in his room without paying. I can't even go out to eat at all. I'm bringing all of my food with me in the back of the car. So we'll use the microwave in the room to cook whatever I'm going to eat. And because I couldn't even afford to go to McDonald's. I will be there with zero money. So, but I'll get to go. And, you know, being able to go is better than not being able to go. So that'll be interesting. Otherwise, that's it. I will see you guys next week. Thank you so much for joining in. I am going to go get this one printed because now that design is so freaking hot that I want to print this now. I really, really want to print this. In fact, that's strong enough that I wonder if I could get away with printing it thinner. If I can have enough structural strength in the model, could I get away with printing it at a 0.3 millimeter extrusion? Because that would reduce the mass of the model by 25%. It'd be 80 grams instead of 107 grams. theoretically that could work. But the problem is if the walls get too thin, then the ejection gas can melt through the wall. So we'll have to see. All right, I will see you guys later. You have a great day, and thank you for joining in. And don't forget, I got PayPal and Patreon links down in the description, and that Amazon link. That's where I make half of my money. When you guys shop on Amazon, use that link to shop on Amazon, and I get a small commission. So that's it. You guys have a great day.